Yeah, my name is Simi Dalalawani, and this presentation is going to be based on random forest as a machine learning algorithm. Here we have the outline of this presentation. What is random forest? Random forest is a supervised learning algorithm developed by Leo Brayman. Random forest works by combining multiple outputs of decision trees to reach a single result. It's quite flexible and easy to use. Even without parameter tuning, it produces a good result. Random forest is one of the most used algorithms for modeling because it's simple and because of its diversity. It, being that it can be used for both classification and regression tasks. Further explain what random forest is all about. I'll be using a real life analogy to do this. A student named Ben wants to undertake a degree at the university and is confused about what course to go for based on his educational background. So he went around to talk to his teachers and his former schoolmates and colleagues. Each of them suggested different courses for him based on what they knew about him. So afterwards, he decided to go for the course that was most suggested by the people he consulted with. So here on this particular slide, you can see that the various people that he spoke to represent the decisions, and then the questions he asked people represent the decision tree activity. So the final course he went for represents the output decision. That's the course that most of his friends suggested represents the output decision. I will quickly go over decision trees being the building blocks of random forest model. Imagine having this data set of two ones and five zeros, and we have to split this data set according to their features. So color seem like pretty obvious feature to split by, as all but one of the zeros are green. So we can use the question, is it red, to split our first node. You can think of a node a as a tree. I mean, you can think of a node in a tree as a point where the path splits into two. So observations that meet the criteria go down the yes branch, and the ones that do not meet the criteria go down the no branch. The no branch, the greens, are, are all zeros now. So we are done with classifying that aspect. Our yes branch can still be split further. Now we can use the second feature and ask, is it underlined, to make a second split. The two ones that are underlined go down the yes sub branch, and the zero that is not underlined goes down the right sub branch, and we are all done with classification. In real life, our data will not be this clean. The logic a decision tree employs remains the same. Have a graphical representation of bagging. Bagging, also known as bootstrap aggregation, is the ensemble technique used by random forest. Bagging chooses a random sample from the dataset. Each model is generated from samples, that's bootstrap samples, provided by the original data with replacement known as row sampling. The step of row sampling with replacement is called bootstrap. Now, each model is trained independently, which generates results. The final output is based on majority voting after combining the result of all models. This step is known as aggregation, and some people call it averaging. Here we have some hyperparameters of random forest classifier, which I'll be using in the next slide for my implementation. N estimator takes an integer value which represents the number of decision trees the algorithm builds. Criterion is a tree specific parameter. It takes either Gini or entropy to represent the quality of a split of the decision trees. N features takes an integer value to represent the number of features when it feat is performed. Mass feature provides the maximum number of features to consider when looking for the best split. Mean sample leaf takes an integer or a floating value. This determines the mean number of samples required to be at a leaf node. n job takes an integer value, by default it is none. It represents how many processors it is allowed to use. A value of -1 means that all processors are available for use. OB score takes a Boolean value, by default it is false. For random state, the model will always produce the same result when it has a definite value of random state with the same hyperparameters and training data. In this section, I will build a random forest classifier using ArcDisease datasets that I've downloaded from Kaggle. It can be seen here that I've read in my data into this notebook. The idea of this project is to determine if a patient is at risk of having a heart disease. So I have imported the required libraries here. And this is what our dataset looks like. It has about 918 entries and 12 columns. However, for this project, I'll only be using 9 columns out of the 12 columns for the modeling. So I had to convert some of the columns to their dummy variables by using the getDummy function from pandas. The sex column has been converted here. The ST slope column has been converted here. And the chest pain type column has been converted here. And this is what our dataset looks like after all the conversion has been made. Now let's get into splitting our data. So I had to split our data into the independent features and target feature. The target feature for this modeling is the heart disease. So now I also had to standardize our independent features by using the standard scalar method from sklearn. I did that here. Next step is to split dataset into training and test data. So 10% of the entire process dataset makes test size. I have specified that here. And then now we're going to building the random forest classifier. I have to import my random forest classifier from the sklearn example and specified my hyperparameters and fitted in my X train and Y train and ran it. And now I can now do some prediction on my test data. So the first result I got, accuracy score I got was 85%. 85%. So I did some hyperparameter tuning with research CV, imported research CV from sklearn model selection, and I specified my hyperparameters and it selected the best score, which is about 86%. I also used feature importance variable to check for least important feature, which is TA here. As you can see, it's TA here. Here's the data visualization of the important features, and the least important feature is still TA the visualization. Now I had to drop my TA and I did my modeling all over again, and I got an accuracy of 90%. Random forest is commonly used in finance to help reduce time spent on data management and processing tasks. It is used to evaluate customers with high credit risk and also for fraud detection. In e-commerce, it is used for recommendation engines for cross-sell purposes, while in healthcare, random forest algorithm has applications within computational biology, allowing doctors to tackle problems such as gene expression classification, biomarker discovery, and sequence annotation. Here are some of the pros and cons of random forest compared to decision trees. Decision trees run the risk of overfitting as they tend to rightly fit all the samples within training data. However, when there is a robust number of decision trees in the random forest, the classifier won't overfit the model since the averaging of uncorrelated trees lowers the overall variance and prediction error. So basically, random forest helps in reducing risk of overfitting. Secondly, it provides flexibility. So random forest can handle both regression and classification tasks with high degree of accuracy. Thirdly, it's easy to determine feature importances. Random forest makes it easy to evaluate variable importance or contribution to the model. Here are some of the cons. Random forest can be time consuming because it handles a large number of data. So it will take time to process this data. Secondly, because of the large number of data, it requires more resources to store this data. Then thirdly, it can be quite complex because the prediction of a single decision tree is easier to interpret when compared to a forest of them.